the generative AI capabilities of LLMs.
Thanks, Larry. All right, so we'll take it from here. I'm Andrea. I'm a CEO, and this talk is going to be about knowledge graph, SEO, and large language models. So we want to walk through a few territories, and these are kind of the main topics. And I don't know how many of you are into SEO. Anyone? Slight interest in SEO, kind of, you are into a little bit. Yeah, you do. Good. Right. So we work with clients to build knowledge graphs that are, designed and optimized for improving organic clicks. Okay. Very simple. We've been working on the semantic web space for many, many years. And then all of a sudden, I found out that SEO was the way. Simplest way to speak with clients around the world about the beauty of building knowledge. It's a pivotal time because we are witnessing a shift on how people are consuming information, and we're moving from traditional search to conversations. There is an increasing competition in general in SEO because of all the AI content that gets generated. There is a growing number of generative AI search engines that we're starting to look into. They're generating traffic to our clients' websites. And I see for SEO, this is a tremendous opportunity because it's not going to be just about Google rankings, but SEO, it's kind of, in between. So yeah, search has changed dramatically, and we've seen with the introduction of ChatGPT how many times we prefer to talk with an assistant rather than to go through the traditional search experience. And of course, this is also a significant change because it means that if Google has been very responsible with this artificial intelligence, it can no longer be as responsible as it used to be because the competition is there. And, in a capitalistic society, of course, they have to throw stuff now out in order to compete with Microsoft. And that makes it even more interesting for us. Now, I started to use this term, which is large language model optimization, as an alternative for SEO, because of course we want to understand how do we tap into these models and how do we make them aware of what we do, what we sell, what are the products, what are the activities. And reality is that there are a few things that we can do, and using knowledge graph and structured data is definitely something that is still worth doing it. Looking at relevant search intents and kind of focusing on the customer journey, it's becoming even more important because, of course, there is more understanding from Google and these other platforms of what the customer is really looking for. Corroborating data with other data has worked in the past and is going to work even more. So what type of AI can SEO use, and how we can do that? So Fabrice Canel from the Bing team has been product manager for many years, and has been very explicit on things that we can do in order to gain traction on things like Bing Chat. And it's as simple as making sure that your pages are indexable, adding relevant semantic data, make a scroll, and then of course develop your audience, because the brand is becoming more important as the search experience changes. People will start from the brand in most of their customer journeys. We are assisting a paradigm shift from the traditional web, where we have, the old content that gets published and then it's indexed by a search engine and people go there, to a context where the content is generated on the fly, right on the page. Maybe it's a conversation with an assistant on our shopping e-commerce. Maybe it's an image that, kind of represent the product in a context. So it's a significant shift. And I started to map these into this sort of framework where we have the different language models right below, and the different workflows that we can apply above, and the different areas of SEO from, entity SEO, programmatic SEO, multimedia SEO, video SEO. So every model actually enables us different workflow that allow us to create, new approaches to our clients. So AI history in short, one slide. Okay, so how do we represent the last 60 years of AI? Well, basically, we can simply put it as deduction, induction, and abduction. And now we are in the era of abduction, and that means that we have started back in the 50s, the 60s on kind of naming things and creating symbols and building knowledge graph. Then we started talking about linked data, of course, the semantic web, and then we have seen the tremendous uptake of language model. There are statistically driven machine that can predict the next sentence, the next word. Now, in abduction, we start to blend these two, and that's what we're going to see in today's presentation. So in 150 years ago, Pierce has started to theorize on abduction, and we don't really have a theory of abduction, and that's something that we desperately need as we are starting to combine the inductive and with the deductive approach. Primarily also because we learned along the way, and Greg is an American software engineer. He's working at IBM. He's been well known for being the inventor of the unified modeling language. And he say that, of course, by design, every transformer, will hallucinate. And so that's, in a way, it's a feature of these statistical models. And of course, how do we make them better? So if on one side they tend to hallucinate, and of course there are other implications that we should take into account, such as, of course, the environmental impact, the fact that we do not know exactly the training data that has been used in most of these models. So sometimes they appear to be magic simply because we don't have access to the data, or we don't have enough visibility of the way in which they operate. And so this is a very important paper that I always bring, this slide up front and say, okay, before we talk about language model, let's try to understand also their limitation. But this is Sam Altman that kind of complements what Gary was saying about language models. That these models are actually reasoning engine and not knowledge bases, and that's interesting because it's from one of the pioneer of the transformer-based era. It's coming, something that I would expect from this community, which is, these language models are a way of reasoning over data, and they're not databases. So we can expect that, whatever they say, it's, potentially factually untrue, but we can use them to reason. And that's what we do with transfer learning, okay? And I'll walk you through a couple of examples of how we use a knowledge graph to transfer learning to language models. And basically, we have two approaches to transfer learning, to convey meanings to a language model: fine-tuning and in-context learning. There are benefits, advantage, and disadvantage in both approaches. And so as we were kind of training this system in order to make them talk like the client, of course I go back to my original law of ontologies, because of course if we don't have enough attributes to map a product, we cannot really describe it. And of course, by doing SEO, I've been always biased to using the schema vocabulary, which is ultra restrictive. But when I have to talk, about, let's say, a product like sunglasses, we realized that we needed, more specifics, and we needed a better taxonomy. And so we started to extend the schema vocabulary and GS1 classes, adding, additional domain classes that would, kind of give us the way of describing sunglasses. And so how do we do fine-tuning? In our platform, we hook a knowledge graph in the backend, and then we use GraphQL to extract properties that are needed for the specific generation task. In this specific implementation, we are generating product description. Okay, so we're doing SEO by creating description of products. We get the data, we analyze the data. Of course, data is sparse, not always consistent, and so we want to see exactly what are the attributes that are recurring the most, and things like that. Most importantly, when we create a prompt, and for anyone that has been, playing with GPT, we all know that there is the perfect prompt, and there is, we have to start with a process. And so, what is this process? It's something that we, allow us to iterate, to make the prompt better, to ensure that based on the data that I have, I can always get, a good result. And so we do this with this interface by, kind of bringing multiple samples in, and with existing data in a template language that says, okay, if we have this property, then say this, and otherwise don't say that. And then, the content team can work on it and kind of find the right way. And of course, we have fine-tuned models that are based on pre-existing data. And then we have validation rules. So we apply a set of validation rules by working with the content team to say, okay, well, when it gets out, for example, rewrite it in such a way, if, I don't know, the material is not appearing, if you want to have the brand up front and stuff like that, an editor would require us. And it took us sometimes for us to kind of organize it in a way that, can be done from an interface. And then, of course, we start generating, and some of the completion are good. So we keep them as valid, and we can bring them live. So SEO, back. So previously we had, a generic product description for all the canonical product, and now we can create, a specific description for the variant. And even though the URL is canonicalized, meaning that the search engine will only look at the main page, we actually saw a tremendous uptake on traffic by doing this. And if you think about it, it's also terrific for the accessibility of our website, because, if I have some level of impairment, I will still have a description that is actually, specific, peculiar for that type of product. And then, of course, we use Google also as a feedback loop, because we want to measure the success by looking at, the organic clicks. And if the organic clicks are there, it means that the content is solid enough for Google and for our clients. And so we tend to create batches, and then over time we measure the performance of, variant and control to see, what performance we're getting. Now, from fine-tuning, which is this approach where we actually create a model that, where the last layer it's personalized, we can move into the more advanced area of in-context learning. In-context learning is where we bring into the context some of the data that we have from the knowledge graph in order to create an experience or a piece of content. And of course, the foundation of it is that we can improve the quality of the generation by aligning the input with the output. And of course, the more accurate is our input, so the more qualified is the data that we're bringing to the model, the better is the output. And of course, a lot of these techniques leverage on what they're called mysterious emergent behaviors of language model, which only means that, we can see some of these behaviors when, the model scales in size, and otherwise it wouldn't be accessible. Now, what are these emerging behavior? Basically, we consider something that it's emerging as, an ability that creates a value that wasn't that we weren't able to predict in the beginning. And this is actually allowing us to reason with the language model and to create, for example, a chain of thought with the language model. And what do we do in order to reason is, of course, to use the data that we have in the model, in the knowledge graph. And so, since prompting is an extremely fragile procedure, we can make minor changes to our data and to the data that we send into the context in order to get the output that we want. And here we can see a basic example where, I ask about myself, and then, there is a statement which is false. But I can correct this statement, because if I ask the model to transform the first description into bullet points and then to evaluate whether the bullet point is true or false, as you will see at the end, I will get the right response, which doesn't include the false statement. So I'm helping the model to take time. Taking time means that the model is thinking about, potential hallucination, and it's, reviewing the final output. So we do this by using knowledge bases. And if you think about it, knowledge bases are becoming more important than language models, because language models are a commodity, whether you're using, GPT-3 or Palm or any other of, the fine-tuned open sourcely available language model. So once again, this is an example of a chain of thought where, in order to get the response, rather than just asking it straight, I ask the model to then reevaluate the response and provide me an intermediate answer. And this is exactly what abduction is about. So we've seen that we've moved from, base language model where, we had this system that we're able to predict similar sentences to instruction-tuned language model, where we actually got the answer. And that's where we are. And of course, a new frontier is opening thanks to reinforcement learning, where we actually provide more feedback to this model. And so as we move from the base language model to a structure-tuned language model, we see that the future is, of course, in building agents, okay? But in order to build agents, again, we need structured data, or we need, semantically rich data. And this is how, we kind of envision the platform that we have, which is, other than a knowledge graph that, gets your data sources and then interacts with the models and then allow us to create these, knowledge-intensive AI application that we specifically designed for the purpose of SEO. So the future of, language model is definitely agentic, meaning that, of course, we can augment the generation with the data. And this is kind of an example of a chatbot that I'm developing that looks at the graph and create indexes based on, the different schema type. So if I have a schema product, I can create a vector store. But then if I have the schema FAQ, the frequently asked question, I can create another vector store. And then I can create a composable graph that would allow, the model to reason and to think, okay, based on the query, where should I get the answer? And this is terrific because we have created a structured model in the backend. Otherwise, it wouldn't be possible. And so that's kind of a basic example of how we are using this also on our own website, and you can see that it's working, meaning that we're moving from creating content to building apps, conversational apps. They use the content but are generated on the fly, and they respond to the need of the user. So whether it's a Q&A system, or it's a platform for doing the structured data audit of your website, simple stuff. I mean, this is from our website, but then of course for a client we do other stuff. And this is kind of the workflow where you have the API and the knowledge graph where everything starts, and then you have this AI ecosystem with the different models, your website, and then these kind of delivery system, distribution system, whether it's a search engine or it's a ChatGPT plugin that allows you to interact with the user. You can play with our app. It's here on the website. And yeah, long story short, we want to focus on our own identity, because as we enter into this post-ChatGPT era, we want to understand, okay, who are we? What are we? Who are we serving? And of course, there is a lot of excitement in AI, but for me, it's important that we keep the focus on creating opportunity for traffic on websites. Yeah, that's just a wrap up. Language models are biased, unsafe, racist, you name it, we know it. Adding a knowledge graph in a feedback loop, it's extremely powerful. And creating tools that allow your content team to interact with these models on one side and to interact with the knowledge graph on the other, it's really what you're looking for, because that creates a data fabric. That's create a means for you to augment your existing data sources. And of course, think in terms not just of content, but of AI application. Think in terms of conversation. Think in terms of how you can make that content more accessible, because that's how users are going to expect to interact with your website and your platforms. And then, last but not least, remember that you need a knowledge graph also because you want to have a validation pipeline. When you generate content, you want to be able to control and validate. Wow, that was fast. We have 1 minute of questions. No, 10 minutes. Okay, good. I've been good. Okay.
Thank you. Really interesting. Could you say a bit more about the knowledge graph? How much is on your side and how much on the client side, and the scalability issues for you being that dependency?
Right. So everything is on the client side and on our side, meaning that we do not control or own any of the client data. The client data belongs to the client. We consider ourselves as a hosting company, so they give us the data, we publish it under their domain with their licensing terms, and so it's all on their side, but we run it. That's kind of how we do it. Now, scalability, it's all microservice based, and so it scales. Then it depends on the use case, of course, because we are live on the website in most cases. We generate the structured data that gets injected on each and every page. In some cases, of course, data is cached by the client front ends. I mean, depending on the architecture. Yeah, we have different implementation.
Thank you. You said, with your last words, you said basically validation is a big point.
It's the biggest.
Yeah, and that is exactly the question that I have. How do you see that validation pipeline? Because, okay, we have a knowledge graph. Yes, we have the knowledge. We can validate it by, okay, I look at it and I go into my database and see what happens. But with the scale of this whole thing, I cannot. Basically have to automatically say that the answer that got out of the system is wrong, and I have to somehow be able to check my performance there. And how do you see that pipeline? Because that's currently a thing that I'm still missing in the whole conversation.
Right. So first, there are different strategies. So there's no one validation pipeline. But let's look at the product description, which is a very simple use case, right? So we get a product description, which means that the model generates something, and it's asynchronous, and we have a set of rules that can be programmed in Python, can also run a language model, because in some cases we found that it's better to kind of give a text and then say, okay, check if this is true or not. In some cases, we extract the properties using name entity recognition, and so if the lens is it's green, we want to check if it's green. So when the content is generated offline, it's quite easy, as long as you have data in the backend, to check a text and to see what attributes you have. Even using a basic GPT models, you can extract the data from the generated text and then check it against your database in the backend. That's one approach. Another approach is that, of course, for example, when we do the conversational interfaces, we use the moderation API from OpenAI that would at least flag if something is, violent or harmful, and that's kind of a basic foundation. The other step is really the chaining of the prompt, because as I show you in the example, if I generate something and then I let the model think, meaning, okay, now based on what you said, create the bullet points for each statement and then validate each bullet point if it's true or false. The performance increases. You still don't get 100%, so there is still a gray area. And that's why I would never come up to, let's say, to her and say, okay, let's bring a chatbot on IKEA. No, we cannot do it at the moment, because the risk of, failing the validation for something that acts live is still too high. But yes, we can generate a lot of, long tail content that would otherwise cost editors a lot of time. And we work with editors, so it's actually a way of empowering them, to give them more tools for creating, more content at scale. So it's also a human in the loop type of issue. So how are we good at involving the humans? It's the same of, is the ontology process linear? Can the domain expert access to it? That's what's make a good validation process.
Thank you. Amazing presentation, Violetta, Ilik. I first want to thank you for using art in your slides. Your profile photo, Caravaggio style, right?
Yes, because it's all about Renaissance. You caught the... Good. Someone understood it.
So you said in the learnings, the first one was that and we know that LLMs are unsafe,
Yep.
biased, and racist. So what are you doing about that?
So, I mean, with fine tuning, you can kind of, get to a level where you can safely use them, because in fine tuning, you give them enough samples that the model is trained to behave in a specific way. The problem of fine tuning is that, of course, is use case specific. So you can generate FAQ content, or you can generate a product description. You can create a conversation with it. So it's limited. And then the rest is really on how you validate the content. What are the steps that are taken before the content reaches the edge? And that's the other point.
Thank you.
One other techniques that we use for validation is also, for example, to evaluate the semantic distance between a synthetic image that would generate with a description with the actual photo of the product and try to see the distance. This is a way that we found valuable for, assessing the quality of the generation.
This is me thinking out loud a little bit and wanting to exchange some ideas. When I kind of saw the whole waves being created by ChatGPT, I realized quite quickly that they're going to kick out all their content creators out of these like companies and just have large language models create the content. And to some extent, it makes sense. I think it's great that you're introducing at least a human in the loop, because that we still need. So it's more like not kicking out people, but just their work changing.
It's a huge change.
It's a huge change, and it's I can already hear the lattice, and it's that. But what I was wondering about, since and you also brought up like the whole that now we have this like Google and versus Microsoft thing happening, since we're still creating content for Google, and Google has an algorithm. Is there a way in which do you think that Google will be developing their algorithm in such a way, because it's always like a catch job with Google, that they're going to develop their algorithm in such a way that it will recognize generated content and kind of skip that or not care about it? What are your thoughts there?
I really advise that, on the publisher front, we start to create the metadata to declare when the content has been automatically generated, not for Google, but for the consumer. Because, we know that watermarking, it's a part of the solution to the problem. Because if I can watermark this image and say, well, this is, has been generated with a language model and use a lot of training data set, and, luckily Caravaggio, it's no longer, copyrighted, then it's safe. So I would advise rather to make the move before Google does it. It's very hard at the moment to understand when a content is generated, specifically if we do the fine tuning that you saw. And especially if you have, the human in the loop. I think what is very complicated is to convince the content team that this is actually a way to helping them and not a way to replace them. And that's where we struggle the most in most of our projects.
I think we might have time for one more question. If anybody, oh, way in the back, sorry. Let me run over there.
Thank you. Thanks. Great presentation. I saw that you'd mentioned LangChain in the presentation, and I've played around a bit with it. I've also played around with semantic kernel. I'm curious your thoughts on why you chose LangChain, how you evaluate it, and what role you see that playing. And it's a second question. From my understanding, for whatever that's worth, I have the sense that, we're fine-tuning these models, GPT-4, and that's great. But I get the sense that GPT-5 is just going to swallow that all up. And so how do we think about this kind of iterative process of, because of like, okay, when the next LLM comes out, how do we think of that process of destroy and rebuild?
Right. So let's start with the second question, which is more broad. I think that to this point, we should have realized that language models are becoming a commodity. So where is the uniqueness then? If a language model will swallow the next one, if fine tuning will no longer be a thing because we can do everything in context, like we started to see happening already, what's left? Where is the competitive edge? Well, guess what? It's in the knowledge graph. It's in the ability that an organization has to control and add value to its own data. And that's it. Because the rest, it's programmable. And why I use LangChain? I think LangChain has, kind of a very interesting approach of, creating these multi-prompts. And it is super simple. But at the same time, if you're into tech, then I would suggest you to look at Llama Index. Because Llama Index is a component that is actually solving a problem that no one understands we all have, which is accessing the data and creating, the best search engine that you need to get the data that you need for that query. And it's way more complicated than just, creating a vector store and bringing all vectors in. It's way more sophisticated. And this is why having a knowledge graph means that I can slice the content down by types, and I can create different index, and then I can use these models to also reason about, what index is best for that query. And combining multiple index for providing an answer. So for example, in some of the, shopping assistant example, the model will combine what coming from the FAQ with what coming from the selection of products that fit with the query, and will create an answer which is quite interesting.
Hey, thanks, Andrea. We're right at time. And thanks everyone for your questions. And we'll have start here in just a minute.